Hi everybody. A month ago I was migrating a customer from an old PBX to a Cisco Core Manager and to a router in order to connect to the PSTN. And so during the migration I had the idea of monitoring data on the router. So I came with the idea of building a container with Grafana, Telegraph, and InfluxDB, with everything being automated so that you could deploy the container and just consume all the data that you find useful. So there are plenty of examples on the internet, and I managed to find one that was not really integrated altogether. So I decided to use that one as a foundation. So the code is not entirely mine. And so, as you know, the Grafana is a data rendering engine that is used to pull data and from InfluxDB, which is a time-based database, right? And so in order to have data into InfluxDB, we are pushing the data through Telegraph. And the Telegraph is a collecting agent, and we will use SNMP on Telegraph in order to retrieve all the data from the CSR 1000V, like the interface bandwidth, the uptime, the number of calls, and I will show you how can we do that. But just before that, just a reminder for everybody. So if you are already familiar with Docker, please feel free to skip the remaining of that video and or maybe fast forward. But we could achieve that with a virtual machine, right? But with a virtual machine, you have to install the operating system, whether it be Windows, Linux, or well, any flavor of Linux that you want. And so you have to manage that. You have to then manage all the specifics, libraries and dependencies for the application that you want to consume. So Docker would leverage the fact that you just have to use the Docker engine in order to have the container built, right? So with the hypervisor, you would have to install the virtual machine, deploy the virtual machine, I should say, install the operating system, and then manage all the objects like the storage, the networking, and then maybe the firewall within the OS, etc., etc. So it can get a little bit complicated to manage that at scale, right? So I'm pretty sure a lot of you managed to see that diagram, and so you have two types of hypervisor: the hypervisor type 1 and type 2. The main difference between the two is that the type 2 requires a host operating system on top of the right below the hypervisor, right? So the hypervisor type 1 is just being installed as the foundation on the server, right? You know, the hypervisor type 1 is known as ESXi, Hyper-V, Xen Server, right? Whereas the hypervisor, the type 2, is more likely like VMware Fusion, VMware Workstation if you are running on a Windows machine, or VirtualBox, right? But still, you will still have to install another operating system within the virtual machine and then manage all the dependencies. So with the container, what you have to do is just to install the Docker software, the Docker engine on the server, right? So let's say you install a Linux server as a bare metal server, right? And on that Linux server, you just manage to install Docker. So now that you have the Docker engine, you can run any container. You can run any container because all the apps and all the dependencies, all the libraries that you need to run that app should be already included in that container. And we'll see how can we do that. So a container will build a file system snapshot, right? It will have a complete isolation with your own file system, right? Using that's because of the namespaces, right? And same thing with the CCG, the common control groups, where you can limit the amount of CPU, memory, and disk that you want your container to use, right? So again, the file system snapshot in a container is isolated, right? So for example, in this example, For example, I have a guest machine which is a Linux, right? That's, well, a host machine, I should say, that is a Linux host. I have my own file system on that Linux host, right? But I install the Docker engine, right? And I install two Docker engines. The nginx, which is in charge of displaying any HTML pages, and a SQL container. These two containers have separate file system snapshots, so they are completely isolated thanks to the file system snapshot and namespaces that we saw in the previous slides. So how can we build a Docker container? So the way we build the Docker container, for example, here I will use a Docker file. The Docker file is basically the recipe of my container. So if I can make an analogy, and I will make an analogy in these subsequent videos. So the Docker file is the recipe of my container. So I will have all the ingredients and all the configuration that I want in my container, and then I will build my container using the Docker build the command line. So the Docker build will bake the container, the container image, right? It will create a file system snapshot, and it will install all the dependencies that I need. As soon as I have my Docker image, I can run that Docker image and create the container that I want using the Docker run the command. So it's a it's a 3 steps process. First, I create a Docker file, which is my recipe. I bake that recipe using the Docker build command to create an image, and then I run that image, and that will give me the container, and that will be the go live of my application, if I can say. So I will show you how can we do that. So I'm in my folder where I have my Docker file. I can have my Docker file, and it's just from Ubuntu 16.04, right? I can show that in a better way with the editor. So it's just one line from Ubuntu 16.04, right? So basically what I want to do is to install a container that has a base image of Ubuntu with the 16.04 version. So let's do that. Let's bake the container now. Let's bake the image. Let's build it. Docker build -t, because we'll give it a tag, Presidio, Ubuntu, and dot, so that we'll use all the files here. So as you can see, it's managed. So I have one step, because I only have one line in my Docker file, and the line says from Ubuntu 16.04, please download that Ubuntu 16.04 and create a file system snapshot, and that's it. That would be my container. So as you can see, the internet is a little bit slow right now, so I will pause the video, and I will resume that when everything is over. So as you can see here, the image has been built based on the fact that it managed to download the 16.04 base image from the Docker Hub. And so as you can see, it will give it a tag. The tag is E1, ends with E1 EB, so we can see that we have it there, right? So now we're gonna run that container. So I'm running that container, and it will give me an ID. So if I do docker ps-a, you can see that ID matches, well, the first digits here matches the container ID that we have here. And you see that the container has been created 7 seconds ago, and the status is up since 6 seconds ago. So now let's go inside the container and see how does it look like. So I'm inside the container. You see, I'm logged in as root, and I can see that we have a regular Linux file system, right? And so that we have the kernel information and the host name here, which is the ID of the container. But the thing is that I can't do anything pretty much. See, I don't have access to ping. I don't have access to pretty much anything, because just by using just a simple Docker file like that, I just install a base image, just the kernel of Ubuntu 16.04. So we'll see in a subsequent videos that how can we do that? How can we add more applications that we will need as a network engineers in order to do our job with DevOps in mind and with more efficiency, so that we can be fluent with automation and DevOps. So I will not stop the container. I will kill it, and I'll see you in the next video.